All right. Hello, everyone. This is me going over the solutions to different lessons. For this first one, I want to go over lesson 2. Okay. So I'm going to do this by looking through the problems here as how you see it. And then also, when it's a math-based, I'm going to write the solutions here. Like I can see this. Oops. And when it's text-based, I'll do the solution on the problem itself. All right. So let's do this right now. Okay. The first problem says, provide a definition and equation of work for A. B, let's say a car is moving at a force of 4,500 newtons, and what will work be if the car moves 20 meters? Explain how you do calculation. The reason why I did explain how you do calculation here is because I can't see you actually do it. But for me, I'm just going to write down basically, I'm just going to do this step by step. All right, first one. So this is number 1. This is the first one, provide a definition of work. Okay. So work is the energy. Oops. So work is the energy transferred by moving an object at a certain distance, sorry about that. With a force. So basically what that tells us is that W, which is an energy, the work, is equal to force times distance. F is the force, D is distance, usually in meters. Okay? So there's that. And then B gives us an actual work problem. Okay, let's see what B says again. We have a car moving at a force of 4,500 newtons, and what would be the work done if the car moved 20 meters? So we know that F is 4,500 and D is 20. Want the units? Sorry about this. 4,500 newtons and 20 meters. So all we have to do is plug in the equation. So 4,500 times 20. And what do we get for that? Well, we can just do 45 times 2, which is just 90. Then there's 3 zeros, so 1, 2, 3, 90,000 and Newton meters, which is the same thing as just joules. That's all you do. 4,500 times 20 equals 90,000. Okay. So let me set up for number 2. Okay. What is the equation for kinetic energy? And then what's the kinetic energy of a 1,500 kilogram car moving at a speed of 20 meters per second? So the first one. First one's easy. What's the equation for kinetic energy? You all should have saw that in the reading or the video. Ke equals 1/2 mv squared. M is the mass, v is the velocity, and we just have a 1/2. All right, let's do B. If we know that M is 1,500 kilograms, and V was, let's look back at the problem, 20 meters per second. I'll just plug in. But this is where I saw a lot of people making the same mistake. So kinetic energy equals 1/2 mv squared. So do that in the bottom. You plug that in, 1500. Now, you gotta make sure you do this. 20, and I'm gonna do this a different color. 20 to the power of 2. 20 to the power of 2. You gotta make sure you square this. So what this actually is, k equals 1/2 1500 times 400. 20 to the power of 2 is 400. Not 20 times 2, not 20 by itself, 20 to the power of 2. So 1/2 or 0.5 times 1500 times 400. And here's a neat little thing about the assessments I've been having you doing. For each of them, you should be able to see a calculator. If it's not on the side already, you need to click on this. And you'll see right here a calculator option. This also works when you do this on a mobile browser on a phone. So you can actually do it here. We had 1/2, so 0.5. It's right there. Times 1500 times, and then 400. That gives you 300,000. So for all these assessments, if you haven't noticed already, I gave you the calculator, so you don't need your own. So you'll need to use your phone calculator. You can use this. This gives you everything you need for like a normal scientific calculators, like the ones I have in class. This is 300,000. So the answer, find my pen. Okay. We plug it all in, is 300,000. That looks like a 6. Let me fix that before you get confused. 300,000 joules. That's the final answer. Okay. All right. Now let's do number 3. This one is with potential energy. What is the equation for the elastic potential energy or spring potential energy? And then if the spring is stretched 4 meters and the spring has a spring constant of 10 newtons per meter, what is the potential energy? So this is just something you should know, but this spring potential energy won't be in your quiz. But let me just go over this either way. So PE, and I'm going to put S for spring, is 1/2 K x squared. K is the spring constant, X is the distance. You can see this is very similar to the kinetic energy equation. So that's A. For B, you just plug in what we know. K was 10, X was 4. Now we just plug it into the equation. So if PES equals 1/2 10 plus 4 squared. So 1/2 10 times 8. Not 8, sorry, I was thinking ahead. 10 times 16. So if you want to show more work, 1/2 10 times 16 is 160. So if you do that, it's just 80 joules. That's it. So now let's do 4. What's the equation for gravitational potential energy, and how much energy does a 70 kilogram person have if they are 20 meters above the ground? G is 9.8. Okay. Okay, so I'm looking at for here. First, the equation for potential energy. PEG. If I only have one potential energy, I usually just put PE because there's no point in putting the other one. PEG equals mass times the gravity constant times height. G on Earth is 9.8 meters per second squared. And sometimes we round it to 10. Just a hint, you're going to round it to 10 in your quiz. But for right now, let's use 9.8. So PEG, you said it was a mass of 70. And we have 9.8. And a height of 20, I believe. 20 meters, yeah. 20. Right, plug that in. Use that calculator. So 70 times 20 times 9.8. Let me check that's right. Yep. And you usually got 13,720 or 13,720. 13,720 joules. That's the answer. You know what? Let me erase the 10. That'll confuse you. Like post this online. So I'll do that. Okay. That's number 4. Number 5 was the hardest one. And let me actually draw that out for you. I remember this one. There was this block, and I believe it's going to be 25 kilograms. Yeah, 25 kilograms, 4 meters. Let's talk about A. So that's going to be our M. Then there's a height. H equals 4 meters. So right now, the block doesn't fall. But for A, we're going to talk about the gravitational potential energy. Remember, that's mgh. And I didn't give you G for this problem, but that's my fault. But you should remember that G is 9.8. So we know every number, mgh. M is 25, G 9.8, H 4. So 25 times 9.8 times 4. So let me do this another color. 25 times 4, right here. It could be 100 times 9.8. And that should be easy. So 100 times 9.8, that's just 980. All right. Now I'll do B down here. For B, I say now the block, the same one, is falling down at a specific velocity. This is the speed it has before it reaches the ground. I put 8.854 meters per second. All right. So for this one, I want you to calculate the kinetic energy. So let's do that equation again. mv squared. Do it down here. Ke equals 1/2 25 times 8.854 squared. Make sure you square because otherwise you won't get the right answer and this won't help you with letter C. When you do that, you should get around 979 point something, but I'll just leave it 979, which is very close to 980 again. Okay, this is 980. This is 980. What do you notice? Well, this is what C is asking for. Compare your answer from A to B. Describe what pattern you notice and what do you think this means in conservation of energy. So what this means, we notice that PE and KE are the same, or very close. That means all of P of the potential energy converted to kinetic energy. Remember, energy cannot be created or destroyed, so this shows conservation of energy. Energy is conserved. What happened in the beginning, the potential energy beginning, is the same as the kinetic energy at the end. That's what happened. How I converted to it? Well, the potential energy, the gravity made the block fall down and build up speed, and that's why the kinetic energy, and all that speed built up kinetic energy, which led it to have the same amount when it started. Okay, so that's it for lesson 2. This pretty much gives you the answers to all of them. I'm going to start doing the solutions to lesson 3. All right, thank you.